Okay, so looking here, we see the DVD machine similar to like what a red box. I'm sure most of you have gotten DVDs out of a red box before. So similar to that. What would happen if I hit A1? What would happen if I hit A1? You guys can just tell me. Hunger Sports would come out, right? So we have this idea of pushing a button and something comes out corresponding with that button. If I hit C2, let's see, the Light Knight would come out. If I hit B3, the Amazing Insect Man would come out. Okay, so we have this idea of all these buttons that we're pushing in a corresponding DVD that comes out. If this machine was functioning properly, because that's what we're going to talk about today is functions. If this machine was functioning properly, on number 2, describe what would happen if I press the same button. So if I walk up, I hit A2 and the Revengers comes out. Okay, and then Sydney walks up behind me and she hits A2. What should happen? The Revengers should come out. And then what if Dom walks up behind me and he hits A2 also? The Revengers should come out. If this machine is functioning properly, every time that A2 button is pushed, the Revengers should come out. What would happen if it wasn't functioning properly?
You might not get Revengers.
You might not get the Revengers. Maybe you get something else. Okay? Alright, so go ahead and flip to the next page. Okay, so we have this idea of inputs and outputs. It says each time you press a button and input, you may receive a DVD or an output. In the DVD vending machine situation, does every input have an output? Yeah? Alex?
Well, what if it's like empty and you press it?
There was a button on there that was sold out. Still an output, right? Even though you didn't physically get anything, the output is nothing. Every time you push that button, does the same result happen? Which button was it? I think it was B1. Every time I push B1, what happens? Nothing comes out. So it may not be the desired outcome, but the output is the same every single time, right? Every time I push A1, the same movie comes out. Every time I push C3, the same movie comes out. All right, so let's flip over to the next. We're actually going to kind of flip back and forth here. I don't really know what it's going to do to the video for me to flip back and forth, but we're going to find out. Okay, so first off, I want to look at this idea of different representations of data, and then we'll go back and talk about, or I'll have you guys put the information into a mapping in a table if we have time. We might not have time. All right, so it says relations can have a variety of representations. Consider this relation 1, 4, 2, 3, 6, 5. That is what relations will look like. They have these little things called braces around them. That was a really bad one. That's what mine end up looking like all the time. They just look like squiggles. See if I can draw a good one. You guys have seen these. That key's on the computer, on the keyboard on the computer. But anyways, that's what they always have around them, and then each ordered pair is in a set of parentheses, okay? And you guys are familiar with ordered pairs. What are those values in an ordered pair? Like, what is 1 for? Over 1 and up 4. So if you're talking graphing an ordered pair, the 1 is which kind of value, an X or a Y value? The X, right? That's the right and left value. And then the 4 is the up and down value, the Y value, okay? So you can see that there are multiple different representations we can use. We can use a table of data. The only thing that's important about a table of data is that every ordered pair, so like this ordered pair 1, 4, 1 and 4 have to be across from each other in the table, right? Because this specific input of 1 corresponds to this specific input of 4, or output of 4 over in the table. Okay, a mapping, the only thing that's significant about a mapping different than a table is that in a mapping we use these bubbles and we use arrows going from inputs to outputs. Also, if there are repeated input or output values, we don't repeat them when we're doing the mapping. Okay, and we'll kind of see that a little bit later. And then a graph, you guys are familiar with a graph. Just remember that first value is your X value going side to side. The second value is the Y value going up or down. Okay? All right, so now let's flip back. So I'm actually not going to flip back because I think it'll mess my video up. But go ahead and scroll up to the previous page, and I would like you to do 4A and B together with your partners. 4A and B together with your partners. Go ahead. All right, guys, so you will notice on my mapping, I know it's not the most beautiful thing that you've ever seen in your life, but on my mapping here, you see I have all of my inputs, and I put a ... down in there at the end because I ran out of room. So I put all of my inputs mapped to my outputs. And notice, since I have two different buttons, two different inputs that go to the Amazing Insect Man, I only write the Amazing Insect Man once, and then I just draw a separate arrow from each of those inputs to that single output. So that's kind of important about a mapping. You don't want to repeat things in the list. Okay, I'm pretty confident you guys can do a table of data. So we're going to move on from this. Any questions? Okay, so go ahead and flip. You guys will actually have to flip a couple pages, I think. Over to number 7. Okay, it says a function is a relation in which each input, that was difficult to say, in which each input is paired with exactly one output. So have a quick 30-second conversation with your groups and talk about, is our vending machine a function? Go ahead. Okay, give me a thumbs up if you think it is a function, a thumbs down if you think it is not a function. I'll do one of each. Okay, we have some people not thinking and some people thinking it is. So we have some yeses and some no's. So somebody give me an argument. Either way. Okay, Ethan, you said no, right?
Yeah.
Okay, why?
Because on the map we made, the C2 goes both to the light night twice, which is.
So C2 and C3 both go to light night?
Never mind, I was wrong. Yeah, that's right. Yeah.
So C2 and C3 both went to the light night. So you're saying that those two inputs share an output. So that's. Oh, so you just changed your mind.
Yeah, I just.
Is there any other no's that want to support no? You proved yourself wrong already? Okay, so hold on, because that was a pretty valid argument I want to talk about. What about this idea that C2 and C3 both go to the light night? How do we explain that away and just say it is a function? Yeah, Sydney, what do you think?
Well, no matter what, if you're pressing C2 or C3, even if you're getting the same movie, it's still an output for both numbers that you're putting in.
Okay, it's very, very important how we read this statement. Each input is paired with exactly one output. Does it say anything about them sharing or not being able to share outputs? Doesn't really say anything about that, right? Think about a candy machine. Okay? You walk up to a candy machine and say, I don't know, I feel like Skittles is a pretty popular candy. Is that accurate? All right, so let's say Skittles is really popular. So you walk up and there is one button that you push to get Reese's, one button you push to get Sweethearts, and maybe since Skittles are more popular, there are two different buttons that you can push to get Skittles so that there's twice as much in the machine. As long as, just like Sydney said, as long as every time I hit the first Skittles button, Skittles come out, as long as every time I hit the second Skittles button, Skittles is coming out, is that machine still functioning properly? Yeah. It is, right? You can think about it with pop machines too. Some of the more popular sodas, like Sprite and Diet Coke, some of those have multiple buttons, whereas maybe something like, I don't know, a Dr. Pepper or some, I think that's a different kind. I don't know. They only have one button, okay? And those machines are still functioning properly. So it's okay that there are two different buttons that lead me to the same output, as long as each individual button has exactly one output, okay? So suppose, then we can talk about number 8. Suppose when pressing button C1 on a vending machine, both the dependables and the light night comes out. So I walk up, I push C1, and the dependables come out. Sarah walks up, pushes C1, and the light night comes out. Is that functioning properly? That's obviously not functioning properly, right? That's one input, one button with two different outputs, two different DVDs that are coming out. Okay, so that's how we know if it's a function or not. All right, so now let's flip over one more page. And I want you guys to, let's see how much time we have. Yeah, we have plenty of time. I would like you to go ahead and do number 10 together with your partners. So do 10, both A and B, together with your partners. Go ahead. Okay, what examples do you have for stuff that does behave like a function? Max?
ATM.
An ATM. Make your case. Why is it a function?
Because it functions. Like, because.
You got to make a better argument than that for me to believe it.
Oh, because it has many different buttons and like different types of money comes out. Like $5 bills, $1 bills.
Have you ever used an ATM?
Huh?
Have you ever used an ATM?
Yeah.
Yeah. It's loosely, I would call it a function because a lot of them now have that quick cash feature. Or if you click on the quick cash button, then it has 20, 40, 60, 80, and you just click on one of those and a different amount of money comes out. I could see that being a function. Okay. Yeah, Logan?
I said a payphone.
A payphone?
Mm-hmm. That's right.
How?
Well, if you put, like, let's say it's a 50 cents one, you can put 50 cents and then you're always going to be able to call a number.
With that description, I would almost lean towards not a function. Because you put in the same 50 cents every time and it calls a different person. You could also make the case, though, can anybody make a case for why a payphone would be a function? A lot of these things are just kind of how you spin it. What do you think, Ethan?
You type in a certain number and it calls one certain person.
There you go. I mean, you could say, okay, the input of this, 10-digit code or 10-digit phone number goes to this specific output, which is this specific person. So you see what I'm saying? It's just kind of how you spin it.
Yeah.
All right. Yes, sir.
A car.
A car?
Yeah.
Okay, make your case.
When you put the key in and start it the same way
Okay, so you put the key in and it starts every time? That's a very, very simple function. It is the one input and one output specifically. So that's fine.
Unless you have to jump start it.
Okay, Max?
An electric bicycle. Like, you know what those are?
Yes. Okay. All right, give me some things that are not functions.
Gumball machine.
Okay, Sydney.
A claw machine.
A claw machine. Make your case.
When you put the money in and you like say like you win, like it's not gonna be the same like stuffed animal or whatever coming out every time.
Yep. So the same input every single time does not guarantee the same exact output every time. There's one input with multiple different outputs on a claw machine. So that's a very good example of one that's not. How about somebody different? Somebody that didn't give me one. You give me one that is a function. Hannah?
Like the little sticker machines where you put like the two cords and then push it and do a different sticker every time.
Okay, so there are a lot of those different kinds of machines, right? That goes for a sticker machine, a gumball machine. When I was a little kid, we had the ones where you could like put quarters in them and like turn the knob, and then one of those little like sticky, stretchy slap hands comes out. You guys know what I'm talking about? Those were the coolest thing ever when I was in elementary school because you could just like smack it on the back of your mom's head and it would stick to her hair and she'd get all mad.
Oh, it was great. One of them got stuck to a ceiling.
Okay, but all of those things, all of those types of things, you put in the same amount of money and you get something different out every time. So that would not be a function. Good. All right, let's move on from there. So now, excuse me. Let's look at 11. Okay, so let's look here. So what are my inputs on A? 11A. Josh?
5, 6, and 7.
How do you know those are the inputs?
Those are X.
Okay, so inputs we know are the same things as the X values, right? That's what we looked at on the previous page. So these three inputs of 5, 6, and 7, do all of those have exactly one output?
Yeah.
What's 5's output?
4.
4. What's 6's output?
3.
3. And what's 7's output? 2. So every single one of those inputs has exactly one output. So is this a function or not? I would say yes, because every input has one output. All right, you guys do B and C together with your partners. Make sure you explain why. Okay, give me a thumb. B, what do you think? Yes or no? Yes or no? B, is it a function or not?
No.
Ooh, I only have a couple yeses. Why is it not a function? Tell me.
Because the two different numbers have the same.
Okay, so my inputs are, 4, 4, and 5. This input of 4 has an output of what? 5. And this input of 4 has an output of 3. That is one input of 4 with two different outputs. So this is not a function. So I would say no, because the input of 4 has two outputs. I skipped an O there, didn't I? Okay, and then give me a thumb on C, yes or no? Man, I see a whole bunch of no's. And a couple people hanging strong with a yes. Okay, why is this not a function?
Oh, do we just shout it out?
Yep, why is this not a function?
Because all the Y's
All the what are the same?
Y, so all your outputs are the same, no matter what you enter, you can get the same output. So that would be a function.
Is that a good argument for why it's not a function? What's the definition of a function? Every input has exactly one output. Does that definition say anything about having multiple outputs? So is it a function?
Yes.
My main men in the corner hanging strong with a yes. They were the only ones that were right. Okay? Even though they share outputs. Again, that goes back to the vending machine that has two buttons that give the same DVD. Right? That's okay. You guys can't focus on the outputs. You got to focus on the inputs. Okay, so this is, yes, a function. And I would say the same explanation I gave up above, because every input has one output. Okay. All right, so go ahead and flip one more page. And this is the last page we're going to use here. So looking at number 2, okay? So we need to take a few notes over on the side. Now we see these different words like domain and range. Okay, these different words like domain and range. So the words that we know are input and output. What is another way to say input? You know them to be what kind of values? X values. So inputs are X values. And we also, a little bit more mathematical term here, we also use the word domain. So the domain is the collection of all the X values or inputs. So input is the same as X value is the same as domain. So all those words are interchangeable. So you can say X values or inputs or domain. And then the other side of the coin is the outputs. And the outputs we know are the Y values. And we also, a little bit more mathematically to go with domain, we call it the range. So we have inputs and outputs, X values and Y values, domain and range. Okay? And all those things are interchangeable. Okay, so for A, what are my inputs or my domain values?
7, 3, and 5.
7, 3, and 5. The important part about domain and range is you always want to put them in the little squiggly braces. Okay, so looking at A, domain, I do my little brace, 7, 3, and 5. Another important thing about domain and range is you never want to repeat values. So say my inputs were 7, 3, 5, and another 3. If there are multiple 3s in the input, I don't repeat them when I'm writing my domain. Okay, and then my range would be 6, -2, and 1. Again, with the braces, 6, -2, and 1. You will see that my braces are never pretty. because they always end up just being squiggles. Just try to make your end brace look as little like a 3 as you can. Okay, because that's the only thing that can kind of get confusing. Okay, is A a function? There are no repeated input values, right? Every input value has exactly one output. This is a function. Okay, I would like you to do the same thing that we just did. Find the domain, the range, and tell if it's a function or not for B, C, and D together with your partners. Go ahead. All right, so for B, my domain values would be my inputs, 2, 6, and 8. And my range would be just 4 and -3. Realize I don't list 4 twice, even though it's an input twice. Okay. Is this a function or not? What about 2 and 6 sharing the output of 4? That's still okay, right? That's like 2 buttons giving the same output. So this is a function. All right, let's look at C.
Is it okay if we put yes or no?
Yeah, that's fine. If you put yes or no, that's fine. All right, C. So generally on graphs, when I'm identifying domain and range, I like to write my ordered pairs next to the dots, just because it helps me keep my X and Y values straight. So I don't care what you do, but this is one strategy that really helps me on the graphs. So this first ordered pair looks like I'm going over 2 and up 4, so that's 2, 4. The second ordered pair here, I go over 3 and up 1, so 3, 1. And this last ordered pair looks like I go over 5 and up 3, so 5, 3. Just a quick little thing that helps me keep my numbers straight. So then I can easily see that my X values are 2, 3, and 5. And my range, my Y values are 4, 1, and 3. Is this a function or not? It is. Every input or X value that I have here, right and left value, has exactly one Y value. What would it look like graphically if it was not a function? Well, that means that one input or X value has 2 different Y values. So if I would go up the line on one of these X values, I would hit more than 1 point. So it would look something like this. Okay, if I have those 2 blue dots there. Now this input of 1, this X value input of 1, has 2 different Y values, up at 2 and up at 5. So that would no longer be a function. Okay, so just graphically that's kind of what it looks like. Alright, and then sliding over to D lastly. My domain, this is what we've worked on already from an ordered pair, -7, 9, and -6. My range, the Y value is 0, -3, and 2.5. Again, this one is a function because every input has exactly one output. Okay. I think the rest of the time is yours.